Alright, so now we're going to talk airplane systems, and this is a bit of a long section, but this is actually where things are going to start picking up, because most of this is either pretty straightforward or they're all simply flags, either a 1 or a 0. So the first system we're going to talk about is the radios. Now the radios, unfortunately, a very limited section on ESP-based sims, so Dovetail Lockheed, some improvement here, definitely warranted. And basically, you just list all the different radio components you can have, which you can really only have these here: audio, 2 comm radios, 2 nav radios, an ADF. You can actually have 2 ADFs too, a transponder, and a marker. And there's just a set of 3 numbers behind them. Most of them only have 1 number. The first number is whether or not that particular component is available. So does it have a marker beacon? Does it have a transponder? Does it have ADF? You get the idea. The second number is whether or not it has a standby frequency. So some models of radios don't have a standby and you swap between them. You have only the active. And this is where you specify that. For example, the King Air, the default King Air, all its radios only have the active, not the standby. So you would set this to 0 if that were the case. But the radios on this plane all have a standby frequency on comms and navs. ADF can also have this, by the way. But transponder, marker, and audio can't. They can only have that first number. And the third number only applies to nav radios, and that's whether or not it has glide slope capability. Both nav 1 and nav 2 can have glide slope. So that is a thing. Alright, the next one is flaps. Now this is followed by 0, just like the start with our flight sim ends section. I'm going to make a copy of this real quick. I'm going to show you how this works. Okay, so the first one is type, and if we bring up our SDK, we see we have 3 types to choose from: either 0 for no flaps, 1 for trailing edge, 2 for leading edge. So you can't actually define the flap type, like is it a Fowler flap, is it a split, is it just a straight flap, but you can define whether or not it's leading or trailing edge. The span outboard is the % span for flap position. The extend time is the seconds in time it takes the flaps to fully extend. That is, go from none to full. The system type is 0 for electrical on this plane, but we can have, let's see here, we can have either electric, hydraulic, pneumatic, manual, or none on here. So we're electric on the Caravan, and for most planes it probably will be electric. But some planes, like the DG808S, have a manual flap position. So, and that, of course, that also defines back to our electrical system. Notice we had the flap motor here. So if this goes out, our flaps die. But if we have hydraulic flaps and the hydraulic pump dies and there's no engine-driven pumps, well, then the flaps also won't work. So hopefully you're starting to see how things start to come together. Now, these two here are damage and blowout speeds. Damage speed, let me read, it might have a specific here. Speed at which the flaps begin to incur damage. Speed at which the flaps depart the aircraft. Now, I don't know for sure. You might be able to tie that to an animation on the plane in the actual 3D model if the flaps completely just disappear from the plane, as if because the blowout speed is the speed at which they will be sheared off of the plane. So if you exceed that with the flaps down, kiss your flaps goodbye. Unfortunately, I don't ever see anyone make use of that. That might not be possible, but I often wonder if that could be tied to an animation on the 3D model. But speed here is where they'll damage, and the speed here is where they'll blow out. So you want this one to be the maximum flap speed from the POH. This one you want to be a little higher. It probably won't be listed on the POH, but you can use your noggin to come up with it. Now the next one is we have a set of positions here. Flap position 0 equals 0, 1 equals 10, 175, that whole thing. So let's look at it. Flap position 0 to flap position N. Each element of the flap position array indicates the direct deflection angle to which the flaps will deflect in degrees. Largest deflection angle will be the one used for the full flap position. I wonder what that second number is then. That might be a speed. Yeah, that looks like a speed there. like a maximum speed. Doesn't look like it. That might be for reference purposes, because the SDK only has one number here, but this actual CFG has two. I'm guessing that must be a speed right there, a speed at which that position incurs damage. The SDK doesn't mention it though. So this is pretty straightforward. Your flap 0 is going to be your up position. Look, interestingly enough, the DG8808S has a negative number. It has -9 for the flap up position. Or no, it looks like it can actually have flaps reverse position, then a flap 0, and then flaps 1, 2, 3, 4, and 5. So on the Caravan, you have your standard 3-position Cessna flaps. Up, 10, 20, 30. And I'm guessing this second number here is the damage speed for them. Not sure, though. Now, there's 3 things you can have on here that aren't actually listed here. And that is lift, drag, and pitch scalars. These are simple scalars that you can have to make the flaps more or less effective, give them more or less drag, and make them cause the airplane to pitch up more or less, basically. 1.0 is normal as defined by Airfile, and you know, it's a scalar. You've probably figured out how that works by now. Okay, so Pitot-Static System. There's only 2 things that you can have here, and that is the vertical speed time constant, usually going to be 1.0, and either a pitot heat scalar. 0 on the pitot heat scalar means no pitot heat available. Increasing it above 0 makes it more effective. I don't think you want to put a negative number here. 1.0 is the normal. So you can have pitot tube icing in Flight Sim X. So the triggers for it are freezing icing conditions. If you fly into icing conditions, which is temp below freezing and visible moisture, i.e. a cloud or rain or something like that, then the pitot tube actually can ice up and your airspeed becomes unusable. So you need to flip the pitot heat on. This scalar will actually define how effective it is at clearing the ice from the pitot tube. Now the other one here is the vertical speed time constant. 1.0 is normal. This is sort of a scalar, but this will increase. Increasing this value will cause a more instantaneous reaction on the VSI. So in real life, the VSI actually lags behind what the airplane's doing. So what you mean by that is when you pitch up to establish a climb, the VSI won't instantly show your actual climb rate. It takes a couple seconds for it to do that. Alright, so the brakes system. There's about 5 things that can be defined here. Parking brake, this is a simple flag, either 0 or 1. 0 for no parking brake, 1 for yes, there is a parking brake. Now, toe brake scalar. Toe brakes is actually, I don't know why they put toe brakes here, but this is actually a scalar of the effectiveness of the brakes. So 1.0 is normal effectiveness. Decreasing this value will make the brakes less effective, and increasing it will make the brakes more effective. So if you find the brakes are too effective on your plane, this is a good place to start looking. However, be aware that if you're using a trigger on a joystick, for some reason the sim will apply the brakes instantly to full with a trigger on a joystick. However, if you're using the keyboard commands, they actually don't instant go to full. They slowly go up to full with the keyboard commands. So this defines the effectiveness of the brake at full braking. So tapping your keyboard will actually not let the brakes get up to full, and you can sort of ease on the brakes like you would in real life. Whereas using your trigger is like full braking instant. So be aware of that. Now, auto brake, this is not a flag. This is actually, you set the number of positions the auto brake can be set to. 0 means it doesn't have an auto brake. Now, I think the RTO position is implied. So you need to, let me see here. Number of increments the auto braking can be turned to. 737-800 has 4. The default 737 had auto brake 1, 2, 3, and max. So auto brakes RTO is implied, so you don't have to count that one. So you just set it to the number of increments it can have, and I guess the highest one it will assume is max. Now also note there are two other things that we can have here that are not mentioned on this particular CFG file, and that is the hydraulic system scalar, which is a simple scalar, 1.0 is normal, and that's the ratio of hydraulic system pressure to maximum brake hydraulic pressure. Don't ask me what the heck that means. The other one is differential braking scale. This is again a 1.0 being normal scalar, but this also lets the airplane know if it has differential braking. Now differential braking is interesting because if you put this here, then the plane gets differential braking, where if you combine a rudder input with the normal brake key on the keyboard, it will have differential brakes. Twist the rudder left with the brake key, activates left brake, twist the rudder right with the brake key, activates the right brake. However, if you assign key commands to left brake and right brake, you can have differential braking even despite this not being there. So this is a thing you should be aware of. Most of the time you can put this there. Most aircraft seem to have differential braking. 1.0 is normal. You can make them more or less effective with that one. Alright, so vacuum system. Max pressure, PSI. Just enter the maximum PSI value of the vacuum system. And the second one is the vacuum type. This is either 1 for engine pump, which is the default, 2 for pneumatic, which requires bleed air, and 3 for Venturi, which I believe is a passive system. 0 means no vacuum. Now, there's a couple of other things here. Electric backup pressure. If you remember back to the electrical system, we actually defined a vacuum pump somewhere, right? Standby vacuum pump value in the electrical system. That ties into this if you have this set. Electric backup pressure. This defines the pressure the electric backup standby vacuum pump is capable of giving the vacuum system. For full effectiveness, go with the normal max pressure. Same here on the electric, but you can make the backup pump less effective, which means not everything will function 100%. And the engine map is the series of flags that correspond to the engines that have a vacuum pump. So for multi-engine planes, it's the simple engine flag thing that we've been doing before, just like we did up here with the engine generator map. 1, 0, 0, 0. And you put a 1 there for the engine if it has a vacuum pump. So the way this works is if an engine with a vacuum pump fails, then that vacuum pump fails, and you need to use the electric standby pump if your aircraft has one. However, if the electrical system fails, or the electric standby pump fails, or maybe the electrical system doesn't have the juice available for the standby pump, then that will fail as well. Now keep in mind, pneumatic is bleed air. That means the engine, obviously the engine has to be running in order for a pneumatic system to function, but a pneumatic type vacuum system can also pull air from the APU. So keep that in mind. But I don't know if that really matters, because it seems that the APU will provide vacuum pressure anyway, even if it is an engine pump type. So moving on, lights. This one's actually pretty neat, and you can actually define quite a few lights here. There's only 4 light circuits listed here. Let me go over to the lights in the CFG file, and you will see there's actually 10 different light circuits you can define, and no real limit to the number of lights the plane can have. So let's go through this. Light 0, this defines which light it is, just standard numerical order. The 3, the first number, is which circuit is the light on. Is it on the navigation light circuit, i.e. tied to the nav light switch, or strobe light circuit, like this one, tied to the strobe light switch, so on. 1 is a beacon, 2 is a strobe, 3 is navigation, 4 is cockpit, but we can also have 5 for a landing light, 6 for a taxi light, 7 for a recognition light, 8 for a wing light, 9 for a logo light, 10 for the cabin lights. These next 3 are just the position numbers of the different lights. Standard, longitudinal, lateral, vertical, plus or minus. We've been through that before. This last one is the effects file. Now, in Flight Sim, you have the effects folder. Let me find it real quick. Here it is. And this is where you define the file name. Now, this has to go into the effects folder. The sim's not going to look for it anywhere else, unlike with some things like gauges where it looks in the aircraft folder first. This here actually looks in the effects folder, and that's the only place it looks. So that effect file has to be here somewhere. That's FX nav red, and if we find it, FX nav red, right here it is. Now, effects files are actually also text files that can be opened with Notepad++, Notepad, or WordPad. As you can see, I have WordPad set to open on files like this. So you can actually do some pretty neat things with this. There's no limit to the number of lights you can have, and you can tie different ones to different circuits too. So let's say you wanted to put a wing ice light on here. First, you got to decide which one you want to tie that to. Probably want to tie that to the wing, a wing light. So you would put that in the position, define which effect you wanted it to be, and you can also tie it to some model variants too. So different textures on the model can be toggled on or off with lights, as well as actual model attributes can be toggled on or off with the lights as well. Now, these days, most payware add-ons tend to go with a different lighting setup where the lights are actually part of the model. So if you see lights that are actually lighting things up in the world and stuff like that, like PMDG, Coronado does this a lot, those lights are not effects files. If you look in their CFG files, they'll have like next to nothing lifted here. They might have the VC light thing, but that's it. Those lights are actually part of the model themselves. Now, this next one is the Autopilot, and we'll set some things up for the Autopilot. I'm actually just going to go through it on the SDK because not everything that the Autopilot can have is listed here. So let's just look at it on the SDK. The first one is a flag. Is Autopilot available? Set to 1 for yes, 0 for no. Flight Director available. Same. It's a flag, 1 for yes, 0 for no. Default vertical speed. Most default airplanes default to 1,800 on the vertical speed. And that's basically is when the VSI is engaged and not preset, what's it going to go to? Auto throttle available. That is the a flag, 1 for yes, 0 for no. Auto throttle arming required. Another flag, 1 for yes, 0 for no. Some planes do not require you to arm the auto throttle. Like say the 737, 747 does require you to arm the auto throttle, but the CRJ doesn't. This one here is the Auto Throttle Max Rpm. This is the maximum engine speed in percent that the auto throttle will attempt to maintain. It will not go above 90%. So if you want it to be able to go up to 100, make sure you set it here. Auto throttle takeoff go around. This is a flag that enables takeoff go around operations within the auto throttle. So does it have a toga, basically? 1 for yes, 0 for no. Default pitch mode. This determines the default pitch mode when the autopilot logic is turned on. There's 0 for none, 1 for pitch hold, which will hold the current pitch angle that the plane had when the autopilot was turned on, and 2 for altitude hold, where it will try to maintain whatever altitude the plane had when the autopilot was turned on. Most default planes use pitch hold, but some planes you might find altitude hold is the default. Pitch, takeoff, go around. Pitch, this is the default pitch that the takeoff go around mode references. So you want it to set a pitch so that when it's enabled, this is more along the lines for go around than takeoff, but when they hit Control-Shift-G to enable toga or whatever they set the key to, that is the pitch it's going to go to. Max pitch is the maximum pitch that the autopilot will use. It won't go above this. Max pitch acceleration, this is the maximum angular pitch in acceleration degrees per second squared that the autopilot will command up or down. Max pitch velocity low altitude, the maximum angular pitch velocity in degrees per second which the autopilot will command when an altitude below that specified in the variable. high altitude, and this is the same thing just for the high altitude above the variable, max pitch velocity, low altitude, breakpoint, the altitude below which the autopilot maximum pitch velocity is limited by the variable max pitch velocity, low altitude. So these two are the altitudes at which these become effective. Max bank is the maximum bank angle in degrees that the autopilot will command left or right. It won't go above this. Now keep in mind you can also set a limit with gauges as well. Max bank acceleration, the maximum angular bank acceleration in degrees per second squared that the autopilot will command left or right. Max bank velocity, maximum angular velocity in degrees per second, which the autopilot will command left or right. Max throttle rate, this is the value set the maximum rate at which the auto throttle will move the throttle position. An example, the maximum rate is set to 10%, the total throttle range per second. So 1.0 is 10%. Nav proportional control, the proportional controller constant in lateral navigation modes. Nav integrator control, the integral controller constant in lateral navigation modes. Nav derivative controller constant in lateral navigation modes. Nav integrator boundary, the boundary or maximum signal error in degrees in which the integrator function is active. In the example, the integrator is active when the error is between minus 2.5 and plus 2.5 degrees from the center line of the navigation signal. Now that has to go with nav hold features. I don't know what any of that means, so please do not ask. Probably best to go with whatever one of the default planes has. Just find whichever default plane is similar to the one you're making and go with that one. I have not a Scooby what that means. The glide slope proportional control, the proportional controller constant in glide slope mode. Glide slope integrator control, same as above but with the glide slope instead. Yeah, all that's pretty much the same. Yaw dampener gain, the proportional gain on the yaw dampener yaw rate error. Direction indicator indicates which direction indicator system the aircraft is being referenced by the autopilot. Attitude indicator indicates which attitude indicator system the aircraft is being referenced by the autopilot. And the default bank mode is when the autopilot's turned on, what's the bank mode it will default to? Either wing level or heading hold or none. Now these two, direction indicator and attitude indicator. This will make more sense when we start going down into the instruments section down here, but you can define a direction indicator and what type it is on the aircraft. I'll go more into it there, but you can have multiple direction indicators and multiple attitude indicators, and which one you want the autopilot to pull from, you specify with those two. Pressurization. Just two simple things to put here. The design cabin pressure, which is the cabin pressure that the plane will attempt to maintain, and the max pressure differential. These are the maximums of the pressurization system. So what's red line on your pressurization gauges? Usually 8,000 works for the design cabin pressure, but maximum differential, that refers to the maximum difference the plane can have between outside air pressure and internal air pressure of the aircraft. None of these key commands are assigned by default, but you can assign key commands to increase cabin altitude and dump pressure. I believe I have mine set to like brackets and backslash, so keep that in mind. Pressurization was a thing with default planes. It's not an add-on thing. Okay, hydraulic system, just three things to set. Normal pressure in PSI of the hydraulic system. Whether or not there are electric pumps available, that's a flag. 0 for no, 1 for yes. And the engine map, which engines have hydraulic pumps. You've seen this enough times, you probably should figure out what that means by now. And Deice system, just one thing to set here. Structural Deice type equals 2 on this airplane, but you can have 0 for none, 1 for a heated leading edge, so heating elements in the leading edge of the wings. 2 for bleed air boots, which is what King Airs and Cessnas and stuff have. And then 3 for engine pump boots. So heated leading edge requires electrical power, and that will pull from the Deice component of the electrical system. Bleed air boots requires a bleed system on the aircraft, which will define somewhere. Pneumatic system right down here. That's defined there. An engine pump requires an engine to be running. Now, obviously, bleed air also requires the engine to be running, but remember, the APU can also provide bleed air, so make sure you put the right one here. This one requires an engine to be running. This one requires bleed air, which can come from an engine or the APU, and then this one just needs electricity. Pneumatic system, just the maximum pressure and the bleed air scalar. Maximum pressure is the maximum pressure available of the pneumatic system, and the bleed air scalar is the ratio of bleed air pressure from the engines to pneumatic air pressure in the pneumatic system. So, as you can see, the Caravan uses 0.15. You'll probably find that higher on jet aircraft, especially Boeings. So that's what that is. This needs to be defined for things that use pneumatic air pressure to work properly. So, if you define a structural de-ice type of 2 for bleed air boots but don't have a pneumatic system, it probably won't work 100% correctly. Variometer, this is just a flag of whether or not there is a variometer on the aircraft. Variometer, I believe, isn't that the beep beep thingy on gliders? Let's find out. Yeah, so that's the thing that can detect thermals on the DG808S. You need to set that to 1. It appears you can have multiple ones on here, so you see how it says a .0? You can have apparently you can have multiple, but there's only one option, either a yes or a no. So, yeah. Now the smoke system, let's see if that has any extra things that are not listed here. Nope. So the smoke system, you really just define the emitter point of where the smoke is going to come from and the effects file you want the smoke system to use. And you can have multiple points. As you can see, we have smoke 0 here, but you can also have 2 wingtip points. You can have as many as you want, really. And this is a good way for, say, crop dusters to define a crop dusting effect using the smoke system. So it's just like the lights, really. Now, the water ballast system, I'm a bit confused on. The first number, I'm pretty sure, is the storage capacity of the tank. The 3 numbers here are position data, and this number I don't know. I'm not 100% sure what this is, and unfortunately, the SDK doesn't really tell us much on the water ballast system. You might be thinking what the water ballast system is. It's used mostly on gliders to balance the aircraft out. The default DG808S has a water ballast system. And at first it looks like you can have several tanks, but it really only has these 5. And I don't know what this number means, and the SDK doesn't tell us much. Tank 0 is always the front fuselage for some reason. Tank 1 is rear fuselage, 2 is left outboard, 3 is left inboard, 4 is right inboard, 5 is right outboard. So there's really not much to go on here. I'm guessing that this first number is the gallons that the tank can hold, and the next 3 numbers of the position, I have no clue what the 5th number is. I can't even think of anything what it might be. Maybe it's a valve, because you have number of release valves here. I don't really know. So yeah, number of release valves, how many release valves are on the water ballast system, and the dump rate in gallons per hour or gallons per second? Gallons per second. How many gallons per second can you dump overboard with the water ballast system? Yaw string, either a yes or no. Does it have a yaw string? Anemometer. Anemometer is the system that tells you what direction and how fast the wind is going. So airplanes that have the ability to detect the wind direction, that is what you put. That anemometer is what does that. It's also a position. So this is your standard lat long and or your standard XYZ coordinates for lateral, longitudinal, and vertical, or longitudinal, lateral, vertical, sorry, of where exactly the Anemometer is on the plane. Folding wings, we got two things we can put in the folding wings section. Wing fold system type is a number that denotes the type. 0 is none, which is the default. 1 is manual, 2 is pneumatic, 3 is electrical, 4 is hydraulic. So this is important because it decides how you can fold the wings. Now, a manual system, you can fold the wings as long as the plane is on the ground. That is someone actually getting out of the aircraft and folding up the wings. Now, a pneumatic system requires bleed air. So you either need to have bleed air from an engine or your APU in order for that to function. Electric requires electrical power in order to function, and hydraulic requires hydraulic pressure in order to function, which means either a hydraulic electric pump or a hydraulic engine pump needs to be on to provide the hydraulic pressure necessary to fold the wings. So keep that in mind. If you ever get in a plane that has folding wings, the wings won't fold up. That's what you should check. What is the requirement? Does it need to have, what type of system does it have? And the other one is just the fold rate. Two values here. The two values, one for the left wing and one for the right wing, or right wing, percentage per second. So you see we have 0.25, so it will fold 0.25% every second. This is for the left wing, 0.2 for every second for the right wing. Anti-detonation system. Now, we talked about the detonation thing with the engines. For piston engines, this is the anti-detonation system. And all this is basically a fancy system that will squirt water into the cylinders to keep detonation from occurring. Refer back to our engine section to talk about what detonation is, but when this system's turned on, it doesn't turn on automatically. It has to be triggered by the pilot, but when it's turned on, the detonation will be delayed. It won't stop it entirely, though. You'll find out why here. So, reservoir size. This is the size of the reservoir in gallons. How much anti-detonation fluid can it hold? Flow rate. What's the flow rate in gallons per minute? So, for every minute, this many gallons is going to be taken from the tank. Reservoir position. Now, the reservoir will obviously add weight to the plane, so we need to define where its position is so we know how that's going to affect the CG of the plane. Then we have max Mp Compensate. This is the maximum manifold pressure that the anti-detonation system is capable of compensating for. So let's go back to our example from the engine. We had detonation occurring at 25 manifold pressure. If we set this to 30, the anti-detonation system, when on, will prevent detonation from occurring for anything below 30. But if the manifold pressure goes below 30 or above 30, then detonation will occur anyway. So this defines basically the point where detonation will begin to occur in manifold pressure, even if the anti-detonation system is on and functioning. Okay, so Nitro System. This is the nitro injection system on the Extra aircraft, the Extra 300S. Reservoir size, gallons. Reservoir flow rate, gallons per minute, same as with the anti-detonation. An MP boost. I believe this is a multiplier. So whatever your manifold pressure is when you engage the nitro system, it's going to be multiplied by this much when the system is engaged. So if we bring up the calculator, let's say we're at 20 on the manifold pressure, and when we engage nitro, it multiplies by that number, let's say 1.25. So we'll get a boost up to 25 manifold pressure. And that scales with your throttle position, by the way. Tailhook, pretty straightforward. Tailhook length, which is how long the tailhook is, and tailhook position. This defines the pivot point of the tailhook. So the pivot point, basically. Not the point that catches the wire, but where the pivot point is. All the systems on the aircraft. Next, we're going to talk about fuel, then we're going to get into instruments, and then we're actually almost done.